In this video, I didn't use any electric potential energy and chemical potential energy, and the thermal energy will only rise through the process. So at first, I will give a force to the books, and the books will fall down like dominoes. So the kinetic potential energy will go up and down, up and down. But they are still on the same platform, so the gravitational potential energy won't change until the books hit the eraser. The eraser will fall down with a higher force than the books, so the connecting energy will rise, and the GPE will fall down as they fall down. And as other things fall down, the GPE will go up and down, and the kinetic energy will go up. And as the GPE won't move anymore as it starts working back on the platform, and the kinetic energy will go higher as the book fall down, the last book fall down with a high force. In this part of my machine, the direction goes from 90 degrees, which is parallel to the floor, to 180 degrees and back to 90 degrees, and it changes for 3 times. Because of the fact that I didn't really use an inclined plane in my machine, so I choose the part where the chopstick brings down the book, because I guess thanks for the friction, the book didn't fly backwards, but it stayed there and then fall down. And the part where I use books as dominoes, there are a lot of air resistance involved. While the book falls down, there will be a large surface area interacting with the air. I can slow down the book by choosing a larger book with a larger surface area, or I can choose a smaller book with a smaller surface area to speed it up. So in this part of the video, I have a eraser falling down at the speed of 0.3. So I am going to times the number 0.3 by 9.8, and then times it again by the mass of the object. The eraser weighs 15 grams, which is 0.15 newtons. So after I calculated, it is 0.441. Because of the fact that my eraser is not taking a force on another object, so I use the domino-like books to give an example of my pressure. The surface area of the book touching a book is 60 centimeters square, and I search up the force of the book touching another book, and it is roughly 5 newtons. So I divide 5 newtons by 60, and I got 0.08. So that is the pressure of the book between book is 0.08 pascals. So now I'm going to do the last part of the calculation. I'll just calculate the work done in joules. And again, I'm going to use the books to calculate this step. I'm going to use the mass times acceleration, and the acceleration of the book is 0.5 meters per second squared, and the mass of the book is 0.8 meters cubed, and while times together I will get 4. So the so the work done is 4 joules.